Hello everyone. So in this video we will be learning about acoustics. Acoustics is nothing but the second topic of our numericals which I will be covering for the GATE exam. So in the vast content of 19 topics we will start from acoustics. Acoustics generally consists of 3 to 4 marks in an GATE exam. It's extremely important in terms of numericals. So definitely one numerical will be asked in GATE exam based on acoustics. Okay, so acoustics is a science of sound that deals with sounds and its various properties. A sound basically has various properties, so acoustics is a science that deals with those properties. Okay, so a sound is classified into three types: infrasound, audible frequencies, and ultrasound. Audible frequencies is the frequencies which is audible to human. So between 20 Hz to 20,000 Hz, human can hear this sound if it's in this range of frequency. Beyond that, it is known as ultrasound, and inferior to that, it is known as infrasound. So what's the difference between a sound and a noise? Okay, so let's consider a sound wave. Okay, this one cycle, this length is known as wavelength of a cycle, and this is known as amplitude. Okay, when the amplitude is uniform, it's known as pure sound, and when there is sudden change in amplitude, it's known as a noise. So these three are the common terms which are associated with sound. Pitch is related to frequency, loudness is related to intensity, and timbre is related to quality. So this loudness is the term which we'll be studying throughout the acoustic terms. Okay, so sound intensity is classified into two. One is the intensity level and second one is the intensity. So intensity level is measured in decibel, dB, and intensity is measured in watt per meter square. So what's the intensity level? Comparison of loudness of a sound directly with threshold of hearing. Threshold of hearing is nothing but I naught. Okay, threshold of hearing is the minimum sound that an human ear can detect. Okay, so direct comparison with this term is known as decibel, and accurate measurement of a sound energy incident on a particular area is known as intensity. So we will see these terms in detail. So in order to measure the decibel level, the formula is beta is equal to 10 log 10 I by I0. Okay, where I0 is the threshold of hearing. So intensity level is nothing but direct comparison with I0. Okay, so now let's see what range of sound an human ear can hear. Okay, so threshold of hearing, that's 10 raised to minus 12 watt per meter square. 10 raised to minus 12 is nothing but 0.11 zeros and a 1. Okay, so that's the range, and that's the minimum sound that an ear can, it is audible to human ear. Okay, so 60 decibels is a normal conversation, and beyond 130 dB it's threshold of pain, and beyond 160 dB our eardrum can burst out. Okay, so that's the level of sounds human ear is audible to. So threshold of hearing is 10 raised to minus 12 watt per meter square. So decibel, that is represented in small d and capital B, is direct comparison with this term, that is 10 raised to minus 12 watt per meter square. Okay, so now let's see some examples. 10 raised to minus 6 watt per meter square is how many decibels? Okay, so this is a shortcut trick. First we'll learn the long one. Okay, so in order to calculate the decibels here, we have to substitute beta is equal to 10 log to the base 10. In question it's given as 10 raised to minus 6 watt per meter square. So 10 raised to minus 6 divided by I naught value. I naught value is 10 raised to minus 12. Okay, By solving this equation, it's nothing but 10 log to the base 10. 10 raised to minus 12 comes up in the numerator, so it becomes 10 raised to 6. So 6 comes in the front, that is 60 dB. Okay, so 10 raised to minus 6 watt per meter square has an intensity level of 60 decibels. Okay, so similarly for 10 raised to minus 6.5, you simply have to substitute 6.5 in place of 6. So for shortcut method, what you have to do is, suppose in question 10 raised to minus 6.5 is given, so you have to subtract that from 12. Okay, you will get 5.5, that's nothing but 55 dB. So in case you are given 10 raised to minus 7.5, okay, that is 12 minus 7 point is 4.5. Okay, 4.5 means 45 dB. Okay, you have to multiply this with 10 and you will get the answer. So this was the shortcut. You need not substitute in this formula and get it again. It's a bit lengthy process, and this shortcut will help you in GATE. Okay, so what if the vice versa of the question is given? For example, in question it's given as 60 decibels is the intensity level. So what is the natural intensity? So all you have to do is substitute in this equation. Okay, so this equation is a derivative of that equation. So this equation is the derivative of this equation. I'll solve and show this to you how it came. So we have the formula beta is equal to 10 log 10 I by I0. Okay, we have this equation. So you take 10 to this side, so beta by 10 is equal to log to the base 10 I by I0. Okay, I am not a great fan of log, but you should remember the basic rules in a logarithm. Okay, so the basic rule says that log of b to the base a is equal to c. If this is the condition, then a raised to c is equal to b. Okay, this is the basic logarithmic rule. So 10 raised to beta by 10 raised to beta by 10 will give me I by I0. Is that correct? So I is nothing but multiply this I0 to this side. So I is equal to I0 into 10 raised to beta by 10. So for example, beta is given as 60 dB and I0 we know it's 10 raised to minus 12 watt per meter square. So solving this equation, we will get I as 10 raised to minus 6 watt per meter square. Okay, so this was the basics. Let's look at some units which are related to these terms. Okay, so sound is measured in decibel. So 1 bell is equal to 10 decibel. Okay, so decibel is the primary unit of measurement of sound level. Okay, sound intensity level. The second unit which comes across is phon. Now phon, I'll explain it as each individual. Consider you and me. Okay, you have a better perception to a sound. Okay, and I am a little bit less perspective to the sound. Okay, which means phon is associated with each and individual. Okay, so each individual has a different perception of sound. Okay, so phon is measurement of sound from a particular individual points of view. So your point of view to hearing a sound may be different, and my point of view of hearing a sound may be different. So phon is the unit which is associated with individual's point of view. Okay, so some sound maybe you might be pleased hearing, and some sound might get me irritated. So it's individuals, based on individual's point of view. So a 60 dB sound with a frequency of 1000 Hz will be louder than 60 dB sound with a frequency of 500 Hz. Okay, so first unit is bell, decibel, second unit is phon, and the third unit we are going to see is son. So son is the third scale which is associated with loudness of a sound. Okay, so here is the sound font scale. Remember this, it's very important. It still hasn't been asked in gate exam, I don't know why, but it's very important. So sound font scale, so one sound is equal to 40 fonts. Okay, so see the sound scale, it's doubling actually. So 1 becomes 2, 2 becomes 4, 4 becomes 8, but the font scale always increases in or decreases in terms of 10 units only. So when the sound scale doubles, 1 becomes 2, 40 becomes 50, 2 becomes 4, 50 becomes 60. Okay, so just remember this, one sound is equal to 40 font. So these were the three basic units which are associated with loudness of a sound. Okay, so here I have some questions. Okay, what is the intensity of a 75 dB sound? So you know the formula, I is equal to I naught into 10 raised to beta by 10. Okay, 10 raised to beta by 10. So substitute 75 decibels in terms of beta. I naught, you know, I naught is 10 raised to minus 12 watt per meter square. So you will get the intensity of 75 dB sound. Okay, if you know the shortcut also. Okay, 75 dB sound, which will have, I guess, 12 minus what gives me 75, it's 45. Okay, so 10 raised to minus 4.5 watt per meter square is the intensity level of 75 dB sound. Okay, try calculating this with this formula, you will find it easy also. Okay, but this shortcut, considering subtracting it from 12, might just save you some time in exam. Okay, so now in second question, what is the intensity level in decibels of a sound wave of intensity 2 into 10 raised to minus 5 watt per meter square? So we know the formula, beta is equal to 10 log 10, 2 into 10 raised to minus 5 divided by I naught. I naught is 10 raised to minus 12. Okay, so solving this equation, you will get the decibel level. Okay, sound intensity level. So as I told you, the human ear, okay, this ear is visible, is audible to, not visible, sorry, it's audible audible to a sound of 10 raised to minus 12 watt per meter square all the way up to 1 watt per meter square. Okay, so see the range of values here, it's a huge value. Okay, which means 0.11 zeros and a 1, it's 10 raised to minus 12 watt per meter square up till 1 meter square. So a human ear has this amount of huge number of values that it can hear. That's why the physicists have introduced the term log into it to make the things a little bit simple. Okay, so consider your ear. Okay, the sound waves are traveling towards your ear and you have an area of 1 meter square in between. Okay, 1 meter square in between. So from this area, if 1 watt of energy passes through it, 1 watt is nothing but 1 joules per second. If 1 joules per second of energy passes through this 1 meter square of area and reaches your eye, then it is a painful sensation. Okay, it will cause you pain and it will make you angry. Okay, you will get angrier. Okay, so 1 watt per meter square is an angry, which means it causes pain, and 10 raised to minus 12 per watt per meter square is threshold of hearing. That is the minimum sound that is audible to your ear. Okay, so I guess you are now familiar with these terms: sound intensity level, intensity, decibels, sound font scale. Okay, So now intensity has the formula intensity is equal to power divided by area. Power is in watt and area is in meter square. So intensity is equal to power upon area. So in order to understand it better, consider a consider a sound source. Okay, consider this as an point source. So consider an ambulance siren. Okay, so whenever an ambulance siren rings, it spreads sound in all four directions. Okay, sorry for my drawing. So it spreads sound in all four directions, which means this point source acts as a sphere. Okay, which means this point source acts as a sphere. Okay, so it releases sound in all directions. So whatever area it inclines to, we know that it's watt per meter square now. So this meter square is nothing but surface area of the sphere. It's nothing but 4 pi r square. Okay, so sound, a point source will act as a sphere. It will release sound in all directions. So that area is nothing but surface area of the sphere. Okay, so intensity is equal to power upon area, that's watt divided by 4 pi r square, which means intensity is inversely proportional to r square. If r increases, intensity will decrease. R increases means the radius of the point source, consider this as r. Okay, so the intensity is I. If the radius increases, intensity value decreases, so it becomes I by 4. So 3r becomes I by 9. Okay, because it's square, so that way it becomes I by 9. Okay, so intensity value decreases when r value increases and vice versa. Okay, so we will only be dealing with the spherical point source. Okay, so in whatever question, if it is mentioned as a point source will be releasing sound, consider that as spherical only. Okay, so now let's solve this problem, a simple problem. Okay, a point source has a sound of 60 decibels at 2 meter. So what is the sound level at 8 meter from the source? Consider a point source, consider this a point source at 2 meter distance, it's 60 decibel. Okay, what will be the sound at 8 meter distance? So at 8 meter distance, what will be the sound intensity level? Okay, now before going to this question, there is a small derivation which I like to show you. Okay, in this question, let's consider I1. I1 is nothing but intensity 1 is nothing but P upon 4 pi r square. Okay, power upon surface area of the circle. Here it will become R1 square. So R1 is 2 meter and I1 is 60 dB. Okay, I2. I2 is nothing but power upon 4 pi R2 square. Okay, so power from the source is the same. Okay, so it only depends upon the distance. So I1 upon I2 will be P upon 4 pi R1 square divided by P upon 4 pi R2 square. To save you some time, P and P will get cancelled, 4 pi and 4 pi will get cancelled, which will ultimately give me R2 square divided by R1 square. Is that right? R2 square divided by R1 square. Now the intensity level of first sound is given as 60 dB, right? So 60 dB is nothing but 10 raised to 12 minus 6, that is 6. So 12 raised to minus 6 watt per meter square. So this is the intensity. Okay, so we have to find I2. So substitute rest of the following. So I2's equation will be I2 will come here, I1 into R1 square divided by R2 square, right? So we know I1 is 10 raised to minus 6, okay? R1 is nothing but 2, R2 is nothing but 8, okay? So this equation will become 2 square divided by 8 square into 10 raised to minus 6, right? So this is the intensity of the sound at 8 meter distance, correct? So what you have to do this, in order to find the sound intensity level, that is beta, okay? So in order to find the sound intensity level, substitute this. So 10 log 10, this is 2 square divided by 8 square into 10 raised to minus 6, the whole divided by, yeah, you're right, it's 10 raised to minus 12 watt per meter square. So solving this equation, you will get the answer. So the sound level at 8 meters from sound is this equation. Okay, it's very easy. So all you have to do is remember this derivation. I1 by I2 is equal to R2 square by R1 square. Okay. Actually, let's solve this only. Let's see what the answer comes as. 2 meter, 8 meter from the surface, no? So it's nothing but 2 square divided by 8 square into 10 raised to minus 6. Okay. So let me use my calculator. 2 square divided by 8 square is 64. So 10 into log 0.0625 into 10 raised to minus 6, and in denominator 10 raised to minus 12, so it comes up, so it becomes 10 raised to 6. Okay, 10 raised to 6, and I'll get the answer 47.95 dB. Okay, 47.95 decibel. Okay, so the sound has reduced from 60 decibels to 47.95 decibels. Okay, so this is the answer. So now we are at inverse square law. Now this is an interesting square law. I like this concept very much. With every doubling of distance, sound changes by 6 dB. Okay, this is an inverse square law. So now with every doubling of distance, sound changes by 6 dB. So now let's see this example only. So at 2 meter it's 60 decibels. So at doubling of distance, which means 2 becomes 4, sound will reduce by 6 dB, which means it will become 54 decibels. Okay, when the distance will increase, intensity level will decrease because they are inversely proportional. So with doubling of distance, to 4 meter becomes 8 meter, so this will further decrease by 6 dB, which will become 48 decibels. See, okay, 48 decibels, the accurate value is 47.95 decibels. So this was the inverse square law concept. With every doubling of distance, sound will change from 6 dB. Now if at 2 meter is 60 dB, so at 1 meter how much it will be? It will be 66 decibels. Okay, so at 0.5 meter, so 0.5, this will further increase by 6, which will become 72 decibels. So that's the trick. Okay, in exam, suppose in the question it's given as answer up to 2 decimal places, which means the examiners are expecting you to give the exact value, which is 47.95. If they have not mentioned anything like up to 2 decimal places, up to 1 decimal place, so you can simply use the inverse square law and get 48 dB. Okay. So that was an inverse square law. So now there are two terms, sound intensity and sound pressure. You might be wondering what's the difference between them. Sound intensity, we saw sound intensity, level intensity. So sound intensity is sound power per unit area. That's nothing but watt per meter square. Okay. Now sound pressure. Sound pressure indicates the amplitude level of a sound at a specific location in space. So consider this a sound wave. Okay. So sound pressure, what it does as, it will indicate the exact amplitude of the sound wave in space. Okay. So that's sound pressure level. You need not concentrate on sound pressure level that much. It's secondary to the sound intensity. Okay. First understand the concept of intensity very well. So intensity's threshold is, we know that 10 raised to minus 12 watt per meter square. Similarly, pressure has a threshold of 2 into 10 raised to 5 newtons per meter square. Okay, or 2 into 10 raised to minus 5 Pascal. Newtons per meter square is also be known as Pascal. Okay, now here we have the formula. This formula is for intensity level 10 log 10 I by I0. Okay, that can be further be solved as 10 log 10 P square by P naught square. P naught square is a threshold of sound pressure. Okay, so from this formula we can conclude that intensity is directly proportional to pressure square. Okay, this is very important. Intensity is directly proportional to pressure square. Okay, so that was a bit theory. And the next, the last for today's class, what will be the addition of sound levels? Consider a speaker. A speaker gives a sound level of 50 decibels. What will be the composite sound level when an additional speaker of 80 decibels is added? Consider yourself in a room. Okay, you are listening to some music with a speaker of 50 decibel. Okay, suddenly your brother or sister comes in. Okay, they have an additional speaker. That speaker is about 80 decibels. Okay, this is 50 decibels, yours one, and your brother has a speaker of 80 decibels. So what will be the composite sound which is produced? Okay, how much in intensity level it will be? So for that we have this formula, beta is equal to 10 log 10 raised to I1 divided by 10 plus 10 raised to I2 divided by 10. So that's nothing but beta is equal to 10 log 10 raised to 50 by 10, 10 raised to 50 by 10 plus 10 raised to 80 by 10. Okay, so when you solve this equation you will get the answer as 10 into log, let me solve in my calculator, 10 raised to 5 plus 10 raised to 8, that will give me a sound of 80 decibels only. Okay, 80.0043 decibels. Okay, so what if your another cousin brother comes? Okay, he has an speaker of, let's say, 100 decibels. Okay, he has a very good, like, ear bursting speaker of 100 decibels. So what you will have to do is uh, delete this plus 10 raised to 100 by 10. Okay, so 10 raised to 100 by 10, and solving this equation you will get the composite sound level. Okay, so this was the addition of sound levels. You cannot add them directly, like 50 plus 80 gives me 130 decibels. It's wrong because it's a log derivative. Okay, we cannot simply add because they are log derivatives. Okay, so I forget to tell you a concept of watt per meter square only. Hmm. Okay, I'll let you know in the next class. Okay, so now let's go through this again. So first we saw acoustics. There are three types of sound: infra, audible, ultra. Infrared has its frequency. Okay. Some common terms are pitch, loudness and timbre. And sound intensity is classified into decibel and intensity level and intensity. That's decibel and watt per meter square. We know the formula to find decibel. Decibel is beta is equal to 10 log 10 I by I0. I0 is the threshold and I is the intensity of whatever sound you have to find. Okay, so this again is the chart. So threshold of hearing, that's minimum hearing and human ear can detect, it is 0 decibel or 10 raised to minus 12 watt per meter square. And you know, normal conversation, threshold of pain and bursting of eardrum. Okay, and then we saw the units. One bell is equal to 10 decibel, phone sound. Okay, remember this phone sound scale, it's very important. So then we saw the derivations for these two, how this equation arrived from this. Okay, then we saw the intensity of 75 dB sound and intensity level of 2 into 10 raised to minus 5 watt per meter square. We saw how a point source acts as a sphere. Okay, so intensity is equal to power upon area, so this area is the surface area of the sphere. Okay, so I is inversely proportional to r square. Distance increases, radius increases, intensity decreases and vice versa. Okay, so we saw how to calculate the distance at what meter, how much intensity level it will be. Okay, so now I'll tell you that concept. Okay, we know that 1 watt per meter square. Okay, 1 watt per meter square is the painful sound. Okay, the painful sound that a point source can emit. Okay, 1 watt per meter square. Also we know the formula, intensity is equal to power upon area. Okay, power upon area. Okay, area is nothing but 4 pi r square. Okay, so I is equal to P upon 4 pi r square. Okay, okay, I is nothing but P upon 4 pi r square. Okay, now here I told you that 1 watt per meter square is a painful sound. Okay, so intensity is nothing but 1. 1 is equal to P upon 4 pi r square. So P is power is also considered as an unit. So 1 is equal to 1 upon 4 pi r square. When you solve this equation for r, okay, so r square is nothing but 1 upon 4 pi. So r is equal to square root of this value 1 upon 4 pi. That will give you an answer of 0.28209 meter. Okay, so remember this value. So when you are at a distance of 0.2821 meter from a point source, okay, that distance will give you power of 1 watt per meter square. Okay, so this is the painful sound. So a painful sound is emitted at a distance of 0.2821 meter from the point source. Okay, so just remember this, it's a very important point. 0.2821 meter is the general radius of a point source where 1 watt per meter square will be emitted. Okay, so this is the radius for the painful sound. Okay, so these were all the concepts which we saw. Okay, then we saw the inverse square law. With every doubling of distance, sound level changes by 6 decibels. If the distance reduces, sound will increase. If the distance increases, sound will decrease. Okay, it's inversely proportional. And we saw sound intensity and sound pressure. P is equal to 20 log 10 P by P0. Okay, P0 is the threshold of pressure, which is 2 into 10 raised to minus 5 Newton per meter square. Pressure is nothing but it indicates the amplitude of the sound wave. Okay, and then we saw addition of sound levels. You cannot directly add 50 dB and 80 decibels because they are log derivatives. So use this formula for n number of sources. Like there are 100 sources, then you will do plus 10 raised to dot 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 dot. Okay. So this was my first class about sorry, not about estimation, but about acoustics. Okay. So if you like this video, please hit the like button. Please subscribe to my channel, and I'll be very soon uploading the video for class 2 also. Thank you very much. Bye bye.